Is Jean still here?
No.
Everybody, is Sharon still here?
Nope.
Damn. Alrighty, back to the grind. Let's take the next one. Let's see. I don't remember.
Live stream was starting.
Live stream. Phew, scram. That is a different one. All right, let's see. Which one should we do? Which one should we do? This guy is kind of pissy. Let's see. Did Sunday like go outside in the front?
Possibly.
Possibly. All right. Let's see what the deal is over here. So I'm not sure that I have all of the parts that I need for difficult 6S backlight, but let's find out. So we did a couple of 6S backlights earlier today that were easy and then medium, and now we're gonna go look for the ones that are harder. All right. What is up with that? All right, let's do this one. And I think I have to start by taking the board out. So let's see. Paul Daniels is awake. He is awake in Australia. It's been like super loud in here all night long, and now it is super quiet. What's up with that? Live stream is a real buzzkill around here, apparently. Evidently. So, Grandma's cat, Blue, that is really on his last legs, ran away. Not really. Like, ran out the door to her apartment, to her condo, and made it to the neighbor's house. And the neighbor kind of hung out with this cat for like an hour while Grandma is frantically looking all around the neighborhood for this cat. And the lady that had the cat went to called the cruelty line because this cat is so skinny because it's like 20 years old. So poor Blue Cat had to go spend the night in the big house and puked all over everybody apparently, but is safe at home. All right, let's get this board out. Let's get this board out. All right. So Christy, you are gonna get that local guy done?
Yeah.
Okay. I didn't make a ticket or anything for him because he actually showed up in the middle of a different live stream from earlier today. Oh, and guess what he does? He is the Diet Coke man. Which is why I had Coke machine on my brain, not because we're gonna start doing cocaine. Not because of that at all. So I watched Dr. Phil today with Bailey when I got home, and we both tried really hard to
therapy after the
yeah, exactly. Oh, I was telling the team here that I accidentally watched a horror film last night with the kids, including my 6-year-olds. It was an accident. I rarely watch TV at all, and I almost never watch live TV. And I was put it on live TV, and you can read the little descriptions of what's on. And there was this movie that was supposed to be about. It was called like Good Choices or something, and it was supposed to be, a guy's a stockbroker and he gets fired and wigs out, and then he decides to, start a new life, and he becomes like New York's, best advice columnist. So I was like, all right, well that sounds like interesting for kids to talk about, and we'll watch that with the kids. But it wasn't that movie. It was this Stephen King movie, 1408, which is a total horror movie. And so we're watching this guy who shit is happening, walls are bleeding, and ghosts are jumping out windows, and And I'm like, okay, this must be the part where the guy's wigging out and he's going to wake up and become an advice columnist. But I kept waiting for that part to happen, and it seemed to be taking a really long time. So and then all of a sudden the movie was over, and I'm like, this was just like not the same movie at all. So everybody's ready to have nightmares about that. But it was an accident, I swear. All right, yes, I remember this one. This is the one that we looked at earlier today and declared that this one is going to go into the not easy category because there is nothing wrong here with the backlight filter, and I believe it has a short to ground, so let's find that out. The easy days are over. Back to hard repairs. Okay, so let's see. Yep, we have a short to ground on the backlight anode line. So let's go ahead and pop off this shield so that we can see the rest of the backlight components and see if we can figure out why this thing has a short to ground. Alrighty. So we're going to take off the shield with hot air. I don't think I can do that under the microscope. It just doesn't quite fit. Move that over. We also need to get the woman from the hate crime phone to do that interview, like now that it's not course week. It's another thing on my radar screen. All right, let's take a look under the shield. All right. Live stream avoidance. You guys are on live stream avoidance? Oh, look at that. A coil shit, my favorite. Look at that coil. Took a shit. Don't you love a cute little coil shit? Look at that coil shit. I love it when it has the little Hershey kiss with the tail. That is really, really cool. I would love for YouTube to make this be the thumbnail for this video. Let's make it brighter. Look at that little cute little coil shit, little Hershey kiss. Isn't that just remarkable? So cool. All right, so it's true that the iPhone 6s backlight coil can take a shit just like the iPhone 6. And look at that diode burn. Wow. And look at the other diode. The little diode has ejected itself. That is just remarkable. Just remarkable. Look at that. See the missing diode there? All right, here we go. That's pretty cool. All right, so missing diode there. This diode has taken a shit. This coil has had irritable bowel syndrome. Look at that. If you erase the shit, that's what's really neat about this. The iPhone 6, you could always tell. But look at that. If you erase the shit, you really can't see that there's anything wrong with this. Like, it looks totally fine. Look at that. And yet we know it is not fine. It is not fine at all. All right, so our primary problem is that there is a short to ground. So let's take a reading here just to show everybody. Full short to ground. So let's review this backlight circuit so that we can all kind of understand what's going on with this. All right. Let's see. How's business going down there, Stephen Remington? With the Wagner. Why are you two trying to avoid streams today? Because both Jessa and Lewis did multiple ones. Yes. Well, this is kind of an extension of the first one. I'm looking to upgrade my Galaxy S5 to either an iPhone SE or 6S. What do you recommend? I don't know. Probably the SE, because it's a sturdy little thing. I love a coil shit. Me too. All right. We both realize we make less than respectable comments and need to take a break. You can see how well that is coming. All right. Okay. Where did that glassy coil poop come from? Is that something that was extruded from the coil casing? Yes. All right. So let's look at how this works. So let me grab the iPhone 6s schematic. So let's go hunt that down. Alrighty. iPhone 6s. All right, let's bring everybody over here to screen. All right, so let's move that. And we're gonna look at the backlight circuit. All right, so the backlight circuit is going to come through J4200. So let's take a look at J4200. All right, here's the connector. A lot of stuff going on at the connector. Move that back over there. And we can see the backlight anode line coming in here to the second pin and the cathode return line. So let's follow this one. So we'll follow the backlight anode line. So we're gonna do copy, paste, follow that along. And we can see that from the connector, there is the classic backlight filter, which in this case is unaffected because the problem was a short to ground on the line. And that's a completely different case than just a straight up connector with a, put on a screen with the battery still connected problem. All right, so here we are back at the rest of the backlight circuit. And we can see what's going on here. So here's the backlight driver chip. The backlight driver chip itself is powered by VCC main. So VCC main plugs into the backlight driver chip, and then the backlight driver voltage, the big backlight voltage, is generated by switching at here and here, switching these two coils. There's a big coil, 15 microhenries, the big coil, the one that took a shit, the big coil, and the baby coil, the little coil. So there's two different coils on the iPhone 6s backlight. There's two different diodes. There is the regular diode, and then there's the glass diode. This is the diode up here that just ejected itself, just took flight and is no longer on the board whatsoever. And then we've got some caps over here. So these caps. So let's look at this entire picture and you tell me what components on here could be the reason why we have a short to ground on the backlight anode line. So we know we can measure. We have a full short to ground over here. Why? Why do we have a full short to ground? Is it the coil? Could the coil be causing a short to ground? Could it be the diode? Could it be these caps over here, like C4020 and C4021? Could it be internal to the chip itself, U4020? Could it be cap 4022 or cap 4023? What are all of our choices here? And then everything else on this side are really just data lines that are going to influence the activity of the driver. So what are our possibilities? Where could this short be? Let's see what you guys think. So let's see if you guys can come up with that. All right, let's see. Let's scroll down, all right? Would have loved to have seen that diode hit the ejector seat in slow motion. Yeah, that would be cool. And it happens a lot, so it's probably possible. We could probably do that. All right, I got a vote for C4022 or C4023. And another vote, so you guys are right. Okay, so many choices, exactly. So the point here is to recognize that you can't have C4020 or C4021 be the reason why I have a backlight anode line short, because if I did, then this phone wouldn't boot at all, because VCC main itself would be shorted to ground. So not him, not him. The coil, the big coil and the little coil, neither one of those guys could be the reason why we have a short to ground, because they have no path to ground. There's no way for them to turn into a wire to ground. That's not possible. So it's not the coil. The coil is not causing the short to ground. Can't be the diode for the same reason. It has no path to ground. There's no mechanism for how this guy could become a wire to ground. All right, so then I have these choices over here. So I've got this little teeny tiny cap, and then I have this great big cap. So either of these could decide to become a wire instead of a capacitor. And if we think about how capacitors work, we can see that they're these little bricks with a shiny side here and a shiny side there. And if we were to look at how they're constructed, we would see that each one of those plates, one on the ground side and one on the line side, have layers that interconnect but don't quite touch. So a capacitor might look something like that. So the only thing it takes to turn the capacitor into a wire is for there to be a connection inside. And then, instead of being a capacitor, it becomes a wire to ground. So it's really easy to see how a capacitor could become a wire to ground. And that can happen when, let's go back over here. So that can happen when we exceed the voltage rating, so 35 volts. We exceed that voltage rating, then the cap will fail, which normally doesn't happen. In the iPhone 6s, it is less common than in the iPhone 6. You'll find these same exact caps in the iPhone 6 are rated for 25 volts, and they upgraded them in the 6s. They're rated for 35 volts. So it is less common, but still possible for one of these caps to fail. So we're gonna guess, if we had to pick one that's most likely, we're gonna guess that it's C4023, the big cap. So what are we gonna do? We are going to see what happens if we take it off. All right, so we're gonna go find C4023, and it's gonna be this big cap right there. All right, so how are we going to actually get this off without bothering a bunch of other dudes on here? So this is all filled with underfill. We know our number one rule is you can't put hot air on an underfilled chip. Whoa, that's loud. Flick it off the board. That would be a good idea. We got a $1 donation, and I can't read the note. I don't think something free USA. I can't read that. And I think it's probably not Jason, but Lewis. I doubt that's Lewis. And I'm sorry I can't read that note. If you type the note on Twitch chat, then I'll be able to see it, or on YouTube, or on YouTube chat. But I can't read it on my open broadcaster. All right, so we need to get this sucker off the board. So if we were to just come in here with heat, that is gonna bother the backlight driver for sure. So we can either suck it up and say, I'm gonna use heat because I know I'm gonna have to replace the coil, I know I'm going to have to replace the diode, and I'm going to have to put back the little diode, I'm going to ultimately have to replace this cap, so I'm going to suck it up and just, use heat around here and replace the backlight driver, even though the backlight driver itself is probably not bad. Or we could go with a drill solution where we would try to drill out this cap, or drill out this coil, and then we could try to drill everything out as well. So that's kind of our two options. Let's start though. Let's see if we can at least solve the short itself without having to do all that. So I'm going to go down to low heat and see if I can just kind of clear out some of this underfill. And we will take that path today. Now there is no rule that says, oh, you got to do it this way, that there's only one right way to do it. That's not true at all. Kind of depends on whether or not you have a backlight driver in your stash. Hopefully we do, but I'm not 100% sure on that. I ordered some, but I might have left them in the truck from the other day because they got shipped to the house instead of the shop for some reason. Okay, so let's go ahead and just take a little low heat and get rid of some of this underfill around here with some tweezers. All right, so the underfill on the 6S is translucent almost, and it is pretty thick and difficult to difficult to work with. Now we can't just use an X-Acto as is and knock this cap off very well because it's got all this underfill around it. Once we get rid of some of that, we may be able to. Since that is my preferred method of removing caps from the board, is knock them off. Alright, well this backlight driver is probably damaged already, in which case no reason to avoid heat on the board. Okay. Alright. Oh, you guys are too fuzzy up there. Let's get that in focus. Alright, now let's see if we can X-Acto this sucker off. iPad rehab, have you ever pulled a pad trace during the knockoff? Well, let's see. On something that I needed to... I mean, most of the time when I'm removing caps, I'm trying to solve a short. And most of the cases where I'm trying to solve a short, I am not going to need to put a capacitor back. So I don't really care if I tear the pads or not. If it's data recovery, I definitely don't care if I tear the pads. And if I'm doing it for the sake of device, then I generally don't care about an individual cap on a line. This cap, however, is required, so I would care in this case, but it is uncommon. In this case, I am fairly confident that that cap was the cause of the short. I could be wrong. So when a cap itself is damaged, it tends to have experienced an insult and therefore be less solidly attached than you'd think. It's been damaged. All right, let's see if we still have a short now. All right, so I'm going to put a probe here on ground and let's test these pads. Ground. Quiet. So now I have solved the primary problem. All right, so now let's look back at the schematic and see, what do you think are the consequences of that primary problem? So let's go back here to screen. So now we know for sure, yep, that guy was a wire. He was short to ground and he's gone now. But when that happened, in that moment where you've got not just your battery voltage, but you had full backlight voltage, that 30 volts maybe, all of a sudden path to ground, no resistance to ground, shooting through to ground instead of going to the screen. That is generating a massive, massive current flow. And what's going to happen next? The little diode, had so much energy, so much heat, it flew off the board. This diode burned up, which we can see. We can see that. We can see the burn mark. We can see that. It looks all burned up. Look at that. That dude is fucked up. So he got burned up. And then in that moment, nanoseconds later, the short to ground happens and then heat. That guy flies away. This guy sizzles and burns, which will then create an open line here on that circuit. And then, at least according to my kind of relatively layperson understanding of how these things work, there's going to be a nanosecond or so where the chip is still switching at the coil, but now there's no path for that output to go. That's an open line. And in that moment, that's when you get this massive amount of heat built up at the coil, and what we can see is that the heat then will burn off the insulation from inside the coil wire, and that's what causes the coil to take that shit as it sends that hot boiling insulation up through the top of the housing of the coil, and that's a big tell. Now, the problem with that normally wouldn't be a big deal. It's still a slinky, it's still a coil of wire, it's still gonna work, except it's going to lose its inductance. So this inductance, the number of microhenries, the ability of the coil to induce a magnetic field, is dependent on the number of turns of the wire. Now, if when the insulation of the wire burns up, that can cause the individual spirals of that coil wire to bridge together, which effectively reduces the number of turns of the coil, and therefore it would reduce the inductance. Now, what's the big deal? What if you plug in a coil that has a lower inductance? The result is if you stick a good diode in there and everything else is working, no short, diode's fine, path all the way out to the connector, chip is fine, it will switch at a coil that now has reduced inductance. And the effect is going to be what? What would your screen look like? What would your screen look like in that situation? Let's hear what you guys think. All right. Both coils, both diodes being replaced. I don't think I'm going to replace the little coil. Let's see. Okay, Amy is not here. Alrighty. Okay, so what do you guys think? What would be the consequence of just saying, coil's still a coil? What's the big deal? Let's see what you guys think. All right. So since I have kind of made a, kind of torn up this chip a little bit, I'm gonna just commit to replacing chip, diode, big coil, and I'm gonna have to come up with another one of these big caps since those are required. So let's get busy and start getting all of this knocked off the board. So I'm gonna go up to regular soldering temperatures and start windshield wipering this whole area. All right, let's get this knocked down. Alrighty. Get some flux on here. I've got one vote for dim or no backlight. Dim backlight is right. You're gonna have a dim backlight, but not no backlight. It's still a coil, it can still induce a little bit, and what you'll have actually happen is the backlight will be maybe 20 to 30% of normal. All right, let's go ahead. It can't boost the voltage without the coil, that's right, but you still have a coil. You just don't have a coil with as many turns of coil wire as you used to have. So it can still boost, just not as much as it used to be able to. All right, so we still have a bit of a underfill dilemma in here. Wow, that's really, really beat up. Really beat up. Let's take a look at that actually. I think this one is kind of a cool view. Let's look at it. Since we know that this coil did take a shit. Let's see if we can tell. I was looking for like visual markings to see the sort of relative loss of insulation. You could probably probe around that a little bit just to confirm that, but that might be too hard. Alright, so we're going to try to desolder this whole thing. And this we'll just have to ultimately pick away. There we go. Alright, now we've got to get the chip off. I love the little green tweezers for picking underfill. I probably wouldn't have to replace this chip if I'd started out with them. Alright, now cleanup time. So these are tough because you've got that strobe driver right there, which is also underfilled and therefore doesn't like heat. So we want to get rid of all of this underfill so that the new chip can dance and find his own way. I'm going to crank the heat back down to low and clear out that last bit. So this is what I mean about why you can't just jump the backlight filter. Because without the filter, then this is the kind of damage that would happen every single time you have a backlight failure just out at the connector from some bozo connecting a screen without disconnecting the battery first. It would be the common fault. Instead, you're only going to have to do this whole windshield wiper repair if you have a short on the backlight line. Alright, now it's time to get an iron in there and clean up these pads. Alrighty. Am I seeing things or did that cap just move? What cap? Which cap are we talking about? Alright, so I'm going to get the big iron out. And let's make it a wet paintbrush. Did Sunday leave?
Yeah.
Alrighty. And then there were two. So Christy, what are your plans for summer? What is your summer gonna look like? Are you doing any camps?
Yeah.
Well, that scares the shit out of me. Mark Wilson donated a $2 through Super Chat. Thanks, Mark Wilson. You're the best. Alright. I keep missing the streams. Well, you're in luck because guess what? This is happening right now. Right now. We are sitting here and desoldering this entire area, cleaning up the pads right now. Right now, as you live and breathe. Alright, let's get in here and clean up that last coil pad. Come on, buddy. Are you the ground side? Don't give me a hard time. Okay, now we're going to do the hardest part of this entire repair, which is look in my 6S backlight bucket and hope to be able to find replacements for all of these missing things. That is going to be the hardest thing that we have to do here. That is going to be our biggest challenge, especially finding, you have to have that big coil, or the big cap. Big cap is required, and he's really hard to find, so he is not a dude that you can just go order on Mouser. Mark ordered like 1,000 of them in the sort of wait 12 weeks and we'll send you your pieces. So that's going to be how we're going to get them in the future. But for now, I think I am going to have to steal that cap, which sucks because I don't have a whole lot of them left. Let's see if I have any of them left. Alright, so cross your fingers. And we're going to look for the big cap first, because that is the holdup. Alright, so this looks like, ooh, the 6S Plus. Alright, let me check to see on the 6S Plus if this dude here is the same guy. Probably is, but I'm not 100% sure. Alright, let's see if, let's just check over here and ask ZXW if ZXW happens to know if that guy is the same. 6S Plus. 6S Plus. All right. iPad Rehab, what's the purpose of underfill other than to make you work harder? Underfill is really a great thing. It does a great job. It is a way for the board to withstand kind of the normal everyday stuff. 10 microfarad, 20%, 35 volt, 0603. So 10 microfarad, 35 volts, 20%. And we're going to look back on the schematic and we're looking for C4023, 10 microfarad, 35 volts. Yay! So that guy is a match. Hooray! So we at least have that going for us. So we're going to get this off here. So if you think about it, especially micro BGA chips, the micro BGA chip has a really substantial footprint that is the same size as a QFN package. However, the number of connections that a BGA chip can make is a lot more than the QFN. So that allows a chip to be more complex, to be able to do things like not just be a backlight, but let's also be a backlight and an ambient light sensor. You know, to have more features in the same relative footprint on the board. That's a huge advantage, but that comes at the cost of stability because a BGA chip is really a plate balancing on balls. So any tiny, you know, get pissed at your girlfriend and throw the phone on the bed, that can, motherfucker, you better get the fuck back here. I know that. I know that. Don't pull a glass diode escape act on me. I'm not having that. Alright, so let's get this back on here before he really leaves. Alright, so let's get this on here. So underfill is really a grand solution to that problem, which allows the board to have really delicate, fine chips with extraordinary complexity in the same footprint as the uber stable chips that we used to use all the time. So it's a good thing. But when those chips fail, or when you have to do work on the board, it is a lot more difficult. It is challenging. Okay, so right now all we care about is really just getting this chip roughly where he's supposed to go. Alright, so that's one. Alright, let's go. It's somewhat terrifying that these 0603 parts appear so large relative to everything else, but that's my normal, non-assisted, visual, practical handling limit. Yeah, those things are a monster. Those things are huge. Huge. Alright, let's see. Uh-oh, I think I have the only driver that's in here I have to reball. That sucks. Boo! Boo, boo, boo. Which really, really sucks, because I know that I just ordered some, and I have a strip of 10 of them laying around. And I'm pretty sure out in the truck. Alright, so let's get out little blue diode. Here, cute little blue diode. Come on, buddy, you don't have to be scared. It's alright. Here you go, buddy. You're gonna love it. You're gonna move in right here. And I think you go like that, but I'm not 100% sure. Let's see if your feet match. Let's look at your feet. Yeah, show me your feet. Yeah, you got a big foot and a little foot. So you go like that. So just hang on there. We're gonna get you a BFF. We're gonna get you a buddy. We're gonna get you a buddy. At least I hope. Alright, now we gotta dig up the other diode. Uh-oh, this whole strip is also glass diodes. Yikes, yikes, yikes. We gotta find a diode. We got to find a diode. I think those are the wrong kind. Nope, they're the right kind. Hooray! Alright, now these diodes, of course, have orientation, so they can't go on any which way. You gotta put them on the way that they go. Which I'm pretty sure is like that. Pretty sure. Let's see if I have a board I can check real quick. Just because I don't want to have to come back around. Alright, which one of you mofos is a 6S? Are you a 6S? You're not a 6S, you liar. Which one of you guys is a 6S? You're a 6. How about you? You're a 6S. Yep. Alright, so we were right. Okay, so let's go ahead and get these diodes down before they float totally away. So I'm going to blow the heat at soldering temperatures away from the strobe driver chip. Strobe driver chip, I would rather not have to reball him. Alright, so we need a little bit of flux. And we have a very high likelihood of my diodes blowing away. We'll try to prevent them from doing that. No. I didn't say you could do that. Alright. That's good behavior, everybody. Okay, now let's get a chip. This is gonna be the hard part. Alright, what's in here? Foil. More foils. How about chips? Are any of you guys chips? Ooh, are you a chip? Are you a chip? You are an iPhone 6 backlight driver chip, fucker. Troll. Alright, what else is in here? You guys don't look like chips. Nope. You guys are diodes. You guys don't look like chips either. Nope, you are more diodes. Fucker, fucker, fucks. Oh, this is painful because I absolutely know that I have one of these chips in the truck, which is at home. But I really want to finish this. So I'm going to have to reball this one that's still in this package. Does Mark have any 6S backlight drivers back there? Should probably go look. Or do you know what happened to the ones that I just... I'm pretty sure I brought them in, but maybe not. Maybe I didn't. Painful. Painful because I hate reballing. I try to avoid it. But I don't think I can avoid it today. My luck has run out. Unless this chip like flat out blows away, in which case I can just leave. Okay, let's turn off this JBC. Oh fuck, we have to leave all this asshole. So be it. So be it. Alright. Alright, there we go. What's going on in chat? I wish there was a way to accept return jobs and have everything bio-nuked before the exchange. That sounds like you guys are a bunch of pussies. That's why it's advantageous to work with a bunch of moms where everybody's pretty used to constantly being shit and puked on. So, you know. Christy, have you ever been really grossed out by a device?
By a device?
Yeah.
Not
I mean,
like
other than the
itself.
data we just recovered.
Yeah,
I mean,
that
that
was
would be
what I was
way
thinking.
up there. Yeah. That is probably the closest to being grossed out that I've been in a while. All right, we got to get that gray pad to be a puffy pillow. There we go.
What do
Yeah.
the backlight drivers look like?
Squares. They look like this upside down. Squares with letters and dots on them. Do you see anything? And they would be called, he would have them labeled like...
Yeah, I don't know about that, but
Like-
she's got a package of other phone backlight drivers, and right next to it, there's a strip of unlabeled.
Unlabeled? Let me see. Could we be lucky? Nope, that's iPhone 6. Whoa! Where did Jean find those, though?
She's got the whole bag over here.
Oh, yeah?
I always look over here when.
I didn't realize Jean was such a thief. I know she had to do 2 6 backlights today, but I don't think she's done a 6S. Alright, let's change the contrast so that it kind of matches what we're seeing a little bit. Alright, let's see if we can dig up some kind of fucking stencil. Have I mentioned that I really can't stand reballing? Plus, what's extra sad is that the same thing in the car, it has my little piece of glass that I like to use for reballing. So, I don't even have that. Great. Alright, which one of you stencils feels like being a backlight driver match? Let's see. How about you? Close enough. Alright, which one of you is not lead free? This is a tiny little chip, so let's see if we can get away with putting the paste on with, God forbid, a Q-tip, because I don't want to get any gloves. There we go. Alright, now let's make some beautiful balls. My wife walked in and was like, whoa, that's tiny indeed. It is tiny indeed. Alright, let's punch the air way down so that we can make some beautiful balls. Alright. And let's hold it down and make balls. And that already sucked because one is a little bit smaller than the rest. So let's see if we can shove a little bit of paste down on that dude. Right there. Maybe you're not as small as I think you are. Oh, sucks. Let's just try to edit that. Let's edit that ball. There, now you're a big ball. Maybe. There you go. Now you're a big ball, just like all the other balls. Speaking of balls, we recovered some data tonight. Okay. Jessa, in your expert opinion, are women or men the best reballers? Probably men, because there's not a whole lot of women that do this at all, and I think 90% of them work in the shop, and none of us like to reball. We don't even like to say the word balls. maybe that's not true, because we do say the word balls a lot, mostly during course week. So I'm going to go with men. Men tend to be cheapskates, and they will sit there and reball chips all day long in order to save 50 cents. I'm going to be pissed if I didn't line that chip up right. It seems to be bigger than I thought it was. I might have missed a whole row. Let's see. Nope, it's not. Okay, good. Sayonara. Alright, let's tighten up those balls. Tighten them up. Everybody likes nice, tight, tidy balls, that's for sure. In fact, I'm not sure that even anybody here has reballed a chip. Christy, have you reballed any chips? Nope. There you go. Not a fan. The reason why... Huh? And you're the only one here. The reason why is because it's introducing a variable, which I try not to do. Okay, here we go. Now let's see if we can... Like this chip. I don't really... There was a reason that I would have put it back and said I could reball this. But I don't know what that reason is. You know, it's fluxy now. I don't know where the dot is. It's kind of hard to find. When you get paste everywhere, it gets... Now you've got paste out that is going to get on stuff. I'm just trying to read it now. I can't tell where the dot is. Come on, dot, show yourself. All right. There's the dot down there. All right, I'm going to check ZXW to see exactly where does the dot go. All right. Why are men cheap? That's all I do is reball. There you go. Are you a guy that would consider yourself cheap? I'm going to go with yes. That's just a guess. I think women are more maybe careful and would prefer to have the variable reduction of using new chips rather than reballing chips. Let's get back to the iPhone 6s. I do agree with Jesso on lazy men, because I'm in transport industry and I'm seeing women truck drivers are in high demand. Alright, men like to play with things that make them feel good. Maybe. Everybody likes shiny balls. I think that if a lot of board repair is just you continue on the way that you start. So if you start out without having a lot of chips, all right, there's the dot. A1 dot is in that location. So if you start out, you know, hey, I'm just going to play around and kind of learn how to do this by taking chips on and off of a donor board and reballing them and seeing if I can put them back on, which is a perfectly fine thing to do, that you might then kind of get into the habit of just, you know, troubleshooting around and picking stuff up and reballing it all the time. And then you might get really comfortable with it and decide, yeah, it's no big deal. I'm 100% confident in my ability to reball. But for me, I never really did that. I was just kind of, from when I started, I was largely using new chips because I wanted to fix things, and I didn't want to have the variable of yet another skill that I would have to master in order to be able to even know if my diagnosis and troubleshooting was right. So I was not really a big reballer to begin with. All right, let's go ahead and get the driver on, and then we will dig up a coil. All right, so we'll go back up to soldering speed and hope this doesn't blow away. No, I'm not cheap, far from cheap. That's what I specialize in. Well, why do you specialize in reballing? Like what led you to that? Is that sort of how you started and then that kind of became your thing? I think, you know, it's the same kind of reason why I cannot work with a Barlow lens and Mark cannot work without a Barlow lens. You kind of continue however it is that you started. Right? Alright, that dude is on. And now for the coil. Now for me, I like to use a 5S or 5 coil. They're all pretty much the same, but I like the form, I like the footprint of these 5S coils because I can put them on with an iron. Alright, so let's grab one. There's one left in this strip. This poor beat up strip. Alright, here he is. See his pads? We're just going to stick them on like that. And solder him on with an iron. The other style of coil tends to be just sensitive, and I think he's kind of a pussy. I like this kind of coil. Alright. Last P phone was a nightmare. I'm thinking of trying a 0.7x Barlow lens to find a compromise between working distance versus magnification. Well, have at it. I like this working distance. I mean, I really do like this tiny little working distance. It just feels incredibly natural for hand-eye coordination, and I think that's a big part of it. Big part of the picture. Alrighty. So that guy is on. So in theory, we have replaced now the backlight driver because of heat. The primary problem, which was this backlight cap, we have replaced the little diode, we have replaced the black diode, and we have replaced the coil. Let's check to see if we have a short to ground. Which, there's no way we're going to have a short to ground now. But let's just make sure. Alright, diode mode is 0.426 and coming up as the board cools down. Alright, and then we can do some other tests. So let's do this test specifically. I'm going to test from one side of the diode to over here, which is on the other side, and I'm getting 0.142. Now I'm going to switch my probes and measure across the diode this way. I'm getting OL. So that means I've got that diode soldered on and all of that seems healthy. Alright, so let's see, should we test? Let's just go ahead and test to see if we have backlight, and if not, then we'll come back and troubleshoot and see what the problem is. But let's just fast forward and test. And then I don't think I have enough parts to do anything with our last job if this one's done, we'll go ahead and even test with his screen. That way, if we're lucky and everything works with no further troubleshooting, we'll have tied all that up. Let's see. Connecting screens is somehow harder than microsoldering. It seems. Got it. Okay, now let's connect a battery, actually DC power supply, and a dock. Here's the dock. All right, moment of truth. Let's prompt to boot. Yay! Backlight is working! Hooray! So there you go. We got that one solved with the big old windshield wiper effect. Let's see. Do you have certification to Master Tech Jessa? Nope, no certification required. You just need to use your brain, solve problems, and think about this stuff and just kind of tease out how it all works together. All right, Mark Wilson, from what I understand, with a 0.5x, you get the 8-inch working distance, so that should suffice you. That said, it's more about the angle you hold the tools out. Well, I think it's more about your brain and hand-eye coordination. If you have to look up with this head angle, it'll never feel natural. So if you are at a Barlow lens, you'll be like this. And that is a very elongated, erect posture. If you, all right, so there we have full backlight. Awesome. Let me do his passcode because I want to make sure that it comes to full brightness. If you have no Barlow lens, then your head is like this, and you're closed in, and that feels very natural. All right, let's see. Passcode. Give me your passcode, dude. Ooh, he did. All right, so now I can go over to brightness. Brightness control. Well, that freaked me out for a second. He was getting notifications that it wouldn't move. So now I can toggle all the way up and I can come to full brightness. Get rid of that. All right, so that looks like normal full brightness, and it does go all the way down. Now if you have a coil problem, it will be dim, and then when you go to slide this up, it just will not get brighter as it goes across. It will stay kind of 20 or 30% dim if your coil took a shit and got rid of some of its insulation and therefore lost some of its inductance. All right, but this one is in the done pile, so that one was hard because we had to both diagnose why do we have a short, even though that was pretty signature. And that leaves us with the last one, which is harder, because I don't know what's going on with it. And I definitely don't have another chip. All right, so this guy is done. We are going to turf this over. Actually, I'm going to put the shield back on. That's important. I don't have any jumpers or anything to cover up. And I think the guy that's in the hard category is also the guy that is the crankiest. He's the kind of guy that's like, according to my calculations, if you will receive my board on whatever day, which means you should be shipping it out and I should be getting it Thursday or something. That might not happen. Well, let's just take a look at it. So I'm just tacking the shield on by holding on to it and getting a little flux, just heating up these joints. There we go. Ready for reassembly. Yep. All right. Is Sharon coming in tomorrow?
Yes.
Okay, good. All right, I'm going to turf all this over to her. Did that phone get invoiced? Is that the one that's charging up that she reassembled?
Which one?
The Rush, no power, that was long screw damage.
Yeah, it's got an invoice number written on it.
Great. All right, I am down to my last of my backlight stack. All right, let's look at this. All right, let's see. What's going on in chat for a second? Why when you yank the diode? What? Watching you on Twitch. Couldn't find why people were typing, but I wasn't seeing anything in chat. Might want to put a link on Twitch page to YouTube Live. That's a good idea. Figure that out. Jessa, when you do a 6 Plus or 6S Plus, do you pull the driver and components on the side you don't use? Trying to figure out why the 6S Plus smoked my not used IC. Do I pull the driver? Hell no. And components on the side you don't use. I don't think I've ever seen a 6 Plus backlight anode line short. So for, I don't fix backlight on water damage, so that might be why, but I don't think I've ever seen a 6 Plus backlight anode line short, period, ever. So then for 6S Plus, I'm trying to think of one that would have a short that I've done. I don't think I've seen it on the 6S Plus either. Just filters, just, deep filter stuff. So no, I mean, I saw that Chris Long, I saw you working on one that one time, and that was water damaged. So that's really, a different beast. I would never try to fix backlight on a water damaged phone, period, ever. So don't know. All right, so I have some kind of jumper. What was I doing? Oh, that's the lung jumper solution. Okay, let's take a look at this board and see. It's in my I don't know what's wrong with it category. All right, let's see what's going on here. All right, so it has no backlight filter, but I took that off, and as far as I remember, this was like yesterday, possibly the day before. It had no short, so let's test. All right, so we get a beep there. And is it short to ground there? Nope. All right, and then this is the side of the filter that goes all the way back to the diode. So let's see, do we have a short to ground there? We do not. And do we have continuity back there? Yes. Which means if we just put a filter there, then everything would be good. And I think I had a filter there and it was not good, which is why I didn't know what was wrong. Right, while we are testing, I don't remember, but I don't think this has an image line problem. So we'll test some image filters and we'll test a image power line for short to ground. Nope. So all of that is normal. All right, so then that kind of puts us out here in the backlight area, but this time we don't have a short to ground. So now this is where it gets odd. Backlights fail by being short to ground. Wait, are you short to ground? I don't think you're short to ground. What was I touching just then? Now let's do a diode mode reading. They fail by being short to ground or by having a open line because of a bad filter. That's pretty much it. All right, so this one was in my neither one category, which is what makes it harder. All right, the backlight anode line is 0.328, which I don't really know if 0.328 is normal or not for a 6S. Let's see what it is on this 6S Plus. 0.507. All right, well, let me see if I can get back the one I just fixed and see what that diode mode reading is. That could be the answer here, that there is a partial short to ground that I'm just not picking up. All right, let's find out. Let's find out. All right, so what is the diode mode reading to ground with red probe on ground on that backlight anode line? 0.47. All right, 0.47. And let me put that board back so I don't lose it. 0.47 and 0.5. That makes 0.328. A little bit low. All right, let's see. All right, get the hell out of here. .331. All right, I'm going to go with 0.331 is significantly low. And let's just do this diode mode reading across here. All right, so here I'm getting a beep, which is not normal. And then this way, I'm also getting a beep, which is also not normal. So a diode, I'm measuring across this diode. What I'm doing is measuring, let's look at the schematic so that we can understand that. iPhone 6S. So when I measure across a diode, I'm measuring from the driver side of the diode. So I was measuring this diode here. So I'm measuring from this position here, which is the driver, the chip side of the diode. I'm measuring across the diode by measuring out here. That's where my other probe point was on the big cap. So I should measure across the diode in one direction should be an open line because a diode can only pass current in one direction. So one direction should be closed. So an open line, nothing can pass, the door is shut. And then the other direction, I should measure a very low, like 0.14 it was on the one we just fixed. A 0.14 means that it can pass current in one direction pretty easily, but not in the other direction. Now here I'm getting 0, a tiny low number in both directions. So that's really hard to imagine because if the diode fails, then you would expect it to just blow up and for you to get open line in both directions. If you're getting a reading in both directions, it really means that that when you put the probe with a pulse here, and then you're collecting it back up here, if it can if it can be collected up here through some other way, some other path, then that can kind of give you an inappropriately low reading for your diode. Which means, what's the most likely way that you could send a pulse here and pick it up over here without going through the diode? And that would be if there is some kind of a path to ground, and that's how that's coming up. So my guess is that because of the low short detection diode mode reading of 0.3 something, which is less than 0.5, and because I'm getting this inappropriate diode reading, that somewhere we have a partial short to ground. So I don't know if that's true or not, but that's what I'm going to go with. So then we're back to that same question of why? Who would fail to create a partial short to ground? Anybody? Could it be the coil? Nope. Could it be the diode? Nope. Diodes and coils can't fail in a way that let them become a little bit connected to ground. They are simply drawbridges. The only thing they can do is blow up. So they can't find their way to ground, but caps and chips can. So let's, again, point the finger at the big cap here and see what happens if we take that off. We're going to take that off and see if our diode mode reading returns to normal. So that would be my plan with this one. All right. Let's skip down to the end. What is this? That one worked. This one wasn't liquid. It was an improper plug-in, which led to no backlight. Alex sent it to me. I got half backlight, and then eventually catastrophic failure of the IC, which fried it. What do you mean? What are you talking about? Catastrophic failure, what IC? And what do you mean fried it? And what do you mean? Why do you keep using the same IC? It's a gamble. Find out more about the optics. She got roasted. What is that talking about? What? I don't know what that is. What? Some people who flick cigarette butts in my yard get double charged. Nice. Let's see. Bad IC driver. Bad IC driver is gonna suck because I definitely don't have another one here. 0.331 does seem like VCC main resistance. Diode is fucked. All right, pace hot air unit. What? Always view your videos, learning new every day. I think the diode is just faulty. Well, how could you think a diode is faulty in a way that lets it be a wire? I don't know, maybe we could take it off. I'm gonna order a quick. They can become reverse passive. All right, well, let's take it off because that's easy. I prefer, let's do it like this. Let's point the finger at the components that Jessa has a lot of and work backwards from there. Because I probably could come up with another big cap. But I definitely can come up with another diode. And it does make sense that this could be, that the diode itself has just become a wire for VCC main. So could be. Let's see. VCC main is 0.3, so it could be just not separating. Could be. And I have a lot of diodes. All right, let's do that first. Sounds good. Destroy plastics. Jessa, do you like your hot air station? Absolutely. JBC, what's your thoughts on it after using it a while? It's the best hot air station that I've ever used and that anyone who has ever touched it has also said, except for one guy. One guy didn't like it as much as whatever it was that he had been using. All right, so let's see. I think there's a lot of underfill in here. All right, we're gonna point the finger at you, piece of shit diode. All right, let's see if we can just blow you out of here. Is that even on? It is on. Just gonna kind of try to destroy it out of here. Oh, my contacts are sticking to my eyes. Time to be done. It is late. Christy, how's general repair queue? Is everything fine?
It's pretty good. Except people keep bringing us iPads they want screens replaced on.
Fuck those. Don't they know that we don't rehab iPads? Huh. What should we do for a sign for outside? I feel like we should get a sign. What should it say? What should it say to everything but iPads rehabbed? Sounds good. Oh man, I need to go to bed. My eyes are really killing me. It's just like a sea of burn up stuff. I think that they are separated, so let's just measure and see whether or not taking off that diode, whether or not I get my resistance back on my backlight anode line. But I don't like it when I don't have a mechanism for, why would a diode just decide to stop being a diode? Why? Why? Why, when the filter was intact? Doesn't make any sense. It would be nice if this was just bad diode, though. Because it would mean I could take out my contact sooner, which makes me really happy. Alright, let's measure, shall we? Now, we're definitely going to have OL. Because this diode can definitely not pass a goddamn thing. Alrighty. Let's see. What is the diode mode reading on backlight anode? Is it still 0.3 or is it back up to like 0.4, 0.5? And it is still 0.319. Yep, 0.32. 0.32. Yep, and we still have a 0 in diode mode across the diode this way and that way. All right, Chris Long, you're fired. Fail, and back to the idea that there's a partial short due to that cap. Alrighty. Okay, get a big sign saying reballers. Let's see what happens if we go back in time and just try to take off this little dude here with green tweezers. Let's see if I can pick underfill with the green tweezers in a way that I don't have to replace the driver chip. Let's see if we can. Alright, so we're going to heat this board up. Let's heat it up. Still have a glass diode on that line? Yeah. I do, but I'm not taking him off because that guy doesn't do anything. I've never seen him have a fault. Have you? I mean, I'd be stunned. We took your idea first. Now we're gonna do my idea. And if this idea also is wrong, then we'll come back to your idea of the glass diode. Because the glass diode can only go on with hot air, and I don't want to use hot air. I don't wanna. What I want to do is have this cap be bad, place the cap, put a new diode on, and have it work again. That's what I want to have happen here. That's what I vote for. That's my vote. Because I need to get the fuck out of here since my contacts are dry like Rice Krispies. I don't really think that bothered the chip, just the paint on top. Way to go, green tweezers. You the man. You the man. You demand. Oh my god, I can hardly see. I can hardly see. I can hardly see. I'd like to pick some more of this out before trying to get that thing off, but I can hardly see. $49 plus tax. Alright, let's just try to get that fucker off. Oh, man. Alright, let's see. Not coming off easy. That means he's fine. Lesson learned. If they don't come off easy, it's because they didn't have anything wrong with them. Oh, he did come off. Okay, now. And now, let's see what the diode mode reading is to. Jessa is too civilized. For what? Rage quit? Table flip? I feel like the glass diode was added for front-facing screen flash. The 6S has a front-facing screen flash? What? You mean you can take a selfie with a flash? Is that even true? Someone needs to invent tweezer straighteners. No way, man. My little crochet hook tweezers, I love these things. They are like bent perfectly to like get in all of those things. All right, work hardening is the downfall of fine tweezers, I suppose. All right. It's all type solution. What are you talking about? Let's see. You don't have a donor board you can take the IC driver off? I guess I could, but I really don't want to. I would stop before I would do that because my eyes feel like sandpaper right now. Okay, time for the exciting result. Who wants to know? What is the diode mode measurement now? All right, here we go. Let's find out. Is it Chris Long and the glass diode theory, or is it Jessa's cap was partially short theory? So let's find out. Diode mode is 0.294. God fucking damn it. All right, so not the cap, because the board is hot, so it's going to be down a little bit, but it did not come back up any at all. And we still have a beep through there. If that's that fucking glass diode, I am going to crush it to smithereens. All right. So now I don't have any choice. Actually, I could just flick it off. These things come off all the time. I'll just flick it off. Because if I put hot air to desolder it, that will fuck with my driver. And I don't want to fuck with the driver because I really don't have another driver. Except I've got plenty somewhere at home. Somewhere is my driver delivery. All right, let's go down to low heat. All right, see you later. I will be out of here relatively soon. Yeah, let's just pick all this shit out. All right, so we've had 2 failed theories here. A lot of times with these, backlight circuits are simple circuits. Like the entire circuit is the driver, the cap, the diodes, the coils, the connector, and the filters. That's it. So if your brain hurts, you can always still fix backlight problems by just saying fuck it, replace all the things, and you would probably work faster than all this bullshit. Oh god, my eyes are killing me. You would probably... That's what we do on the 6 now. It's just... Fuck it, I don't care if I have to... Like, I have plenty of drivers in stock. And plenty of caps and coils and everything else. So now, iPhone 6 with any short on backlight anode line just gets windshield wiper done. And that's the deal for all of them. Alright. Let's see. Can we get that sucker off? Let's see. Get it off with no hot air. I replaced all the things and caught the IC on fire. Huh. You did? How many times did you put heat on that IC before it caught on fire? That's what I want to know. Alright, let's see if we can get this thing off without using hot air. I feel like the glass IC is like almost never soldered on like at all. It just lifts off by itself constantly. Stop being a bitch. Get off my fucking board before I just crush you. I'm gonna crush you right now. Fuck you. Fucking whore. You whore of an IC. Alright. The most beat up fucking driver there is. Okay, and now for the exciting answer. What is it going to be? Hot tip on it, then flick it. Yeah, that's totally what I did. New IC. And by new, you mean new, as in go to bed, take out your contacts, get a little rest, and then bring home the fucking strip of ICs from the truck and windshield wiper this area like you should have done to begin with. I agree. That is a great plan. I love that plan. That is my favorite plan. All right, now let's find out with red probe on ground. What is the diode mode reading now? Boom. Fuck you, glass IC. 0.5. Fucking whore. That's it. Death to the fucking glass IC, which, by the way, really isn't required. We had one early on when you couldn't get all these parts and stuff, and there was no schematic, I think. Oh, man. And that driver was burned up on the glass IC, the little coil and the glass IC. Those guys, they go together. So the little coil, glass IC, fuck that whole little coil and the glass IC. So I got one around Christmas time that had a prior repair attempt where they had pulled the pads just for the little diode and the glass IC, or the glass diode and the little coil. So on that one, I decided to do a test and see what happens if I try to power the line just off the big coil and the regular diode, and it was fine. And that one also never came back. So that was December. Now it's June, so that's about 6 months that has had no practical effect to just leave the glass diode and little coil off entirely. Alrighty, so magic smoke involved in this phone. It's sometimes the diode, always the coil. No, it's the fucking diode. I'm gonna make a shirt that says it's the diode. It's the fucking glass ass diode. From now on, I think the glass diode should be like the JTAG connector and just fucking get off the board. Alright, now here's the real challenge, because in theory, I could stick a cap and a little diode on and fuck the glass diode, which is what I'm gonna do. Fuck you, glass diode. You don't deserve to be on this board. Alright. Let's see. If I am going to go incredibly rogue, mostly because of this guy's note. And it's so funny, like you guys are talking on there about how, the guy that flicks cigarette butts in my yard is going to pay more than the nice guy down the street. Well, the guy that sends us according to my calculations, this is going to be back to me on Thursday, when it's like, and then has a strange problem. You, my friend, are going to get chip quick low melt alloy so that I can put some dudes on here with no heat at all, practically. Alright, so we're going to give him a little kiss. A little kiss of chip quick. Maybe a kiss enough to actually do something. Not this much of a kiss. Come on, mofo. Get into that joint. Still busy trying to unsee the data recovery job from before we started the stream. That was pretty horrifying. Alrighty. Now, where was that other 6 plus? 6S plus. Alright, so I'm assuming that that fucker is the same dude. So, we'll try to grab him. Get ourselves a cap. It would be pretty cool to finish this board just to be able to complete the easy, medium, hard, and harder series of 6S backlights. Run away, you piece of shit. Get out of here. Alright, don't run away. Don't run away, you asshole. Alright, let's see if we can not destroy this chip or the CPU. Lay down. Oh. Chris Long, the actual power generated in that circuit looks like it'd be lower because it's a smaller diode in the coil. What are we talking about? There we go. Glass diode is rated higher voltage. What? Dual mode booster. Perhaps at low brightness it actually uses the smaller circuit to be more efficient. Maybe, but it also uses the bigger circuit in order to... Let's get a regular diode. Whenever it wants to. Let's see. Glass diode. Regular diode. Trolled by the glass diode. He should have done us a favor and just ripped himself off the board like all the other good glass diodes do. And just get up and leave. As they should. Alright. Let's see what happens. And we're going to beef up that one joint a little bit. Just to make sure it's a good joint. No, these guys are just not on. There needs to be more puffy pillows. Let's make puffy pillows. Almost done. Let's see. I want to understand why they have two circuits. Does anyone use the 64-bit NAND programmers? Nope, those are expensive. PCB board views. I don't know what you're talking about. I like the Navi Plus, but the IP Box 2 does more. Like what? Does it program the Wi-Fi? Alright. Stripey and beeped and never turned back on. Alright, let's see. I think I'm pretty much ready to put this aside because I'm just too tired right now. But I would like to get one test out of it. Alright, so that is technically on there. Alright, let's let's just get a test out of this before kind of having to do more troubleshooting or cleanup or whatever. Alright, let's see. Diode mode says .404 and climbing, and the board is pretty warm right now. If we measure across here, 0.128, which is good, and then hopefully open line. Open line. Good. All right, let's get it a test. And either way, I think we're gonna be done just out of sheer good old plain exhaustion. All right, we're gonna grab this dude's screen. I still really don't like not knowing. Oh, fuck me. It needs a fucking filter. God fucking damn it. Fuck Fuck you, filter. Alright, we gotta throw a filter on here. Fucker. That would be funny. I'm surprised that I am not too tired to notice that. Because that totally could have trolled me just now. Totally could have trolled me. I would have spent a long time replacing who knows what on here before realizing, oh yeah, I took the filter off yesterday. Oh yeah, I remember that now. Alright. Oh, fuck. And that other dude, the one that I just said was done, now I remember that dude had... That was the one where the guy said, this has never been opened or looked at while in my shop. Which means somebody else, like his DIY customer, trolled the shit out of it. So I think it was missing some dudes down here by front camera, which I'm guessing he would prefer us to fix rather than just ignore. Alright, now let's just make sure. We've got a beep from the land of the cap out here to the connector. Do we? Fucking beep. Thank God. And now we can actually test. And now we can actually test this one and see what the deal is. Trolled by the glass diode. I will say, it wasn't the coil. It wasn't the coil. At least it's not the coil yet. But I doubt it's going to be the coil. Fucking glass diode. Wonder what it's actually made out of. I think I read an article once where all these things that we call glass, they're not really glass. They are just like uncoated silicon. Should look that up again. And that calling them the glass diode is a misnomer. But it looks like glass. Everybody else calls it glass. I'm gonna stick with that. Alright, what's gonna happen? What's gonna happen? I know what's going to happen. I am going to go home. But first, let's see if we are lucky. IC roasting time. I ain't going to roast no IC. I ain't going to roast no kind of IC. I ain't going to see no kind of smoke. I would like to see the fucking thing turn on. I ain't going to roast no IC. Chris Long. Boom. Backlight. Woo woo. All right. Let's see if it will boot and come to full brightness and shut this douchebag up, or if I have to replace the coil, in which case I am going to do that tomorrow, because this one needs some cleaning up. This is just kind of like diag mode to see whether or not we can fix 4-for-4 backlights. Easy. Remember the easy one all those hours ago? The easy one. And all these are the same price. Flat rate. No fix, no fee. Solve your 6S backlight problem, whatever it takes. Easy. And then that one, that was just the filter. Please tell me that you have a fucking passcode. If you don't have a passcode, I'm going to shoot myself in the face. Oh, man. Tell me your passcode. I do not currently have it, but I will get it and provide once requested. I already fucking requested when I told you passcode was required for you to send your device in. Fan-fucking-tastic. Alright, well, we really have no way to... Yeah, passcode. Well, that really doesn't help me. Alright, so Backlight is solved, but we do need his passcode, and that, in order to know whether or not the coil in that case was insulted, because this did have an inappropriate path. It had an inappropriate path through the glass diode. Who knew? Who saw that one coming? Out of all the things that were in this circuit, the only fault was either both the diodes or just the glass diode, as providing a way for the voltage to travel in an alternate path. So remember, when we talked about measuring the health of a diode is supposed to be OL in one direction, to not pass current in one direction. And when you see that it is, that either means that it most likely means that there's an alternate way for the probe that's sending out a pulse to pick that back up on the other side. And if you look back at the 6 diode, you can see the black diode and the glass diode, that you do have an alternate path there. So that's what was going on with this one. This one was the harder one, and previous to that we had the hard one, which was pretty much a windshield wiper of the entire area, but it was a really classic signature fault. Full short on backlight anode line. That's almost always going to be that C4023 cap. But once that cap goes short, it's definitely going to take out your diode. And we even saw it take out the coil and make the coil shit. So that's a classic windshield wiper presentation where you're going to be on the hook for the coil, for the diode, for the other diode, and for the cap, and then the backlight driver if you're going to put hot air on the area to change all of those other components. And before that, we had the medium one. The medium one was super teeny tiny micro jumpers. That was just really a technical challenge, but it was pretty obvious. 2 bad filters in an iPhone 6s Plus. So we had to do some micro jumpers and microsurgery to get those filters on there. So we got that one done. And then all the way back to the easiest one, which was the straight up classic iPhone 6s backlight failure. Alrighty, so now we have done our 6S backlight series from easy, medium, hard, and harder, and it is time for bed. That's it.